Let's solve this integral.
The definite integral of sine squared x times cosine cubed x dx evaluated from 0 to pi halves is a basic trigonometric integral. Our goal when we see an integral like this is to be able to use u substitution to solve. Whenever we have a trigonometric integral with a trig function squared and a trig function to an odd power, we're going to want to break that odd power off so that we're left with one of those trig functions as our du. So in this case, we would break cosine cubed into cosine squared times cosine to the first power and use cosine to the first power as our du. Since our du is our derivative of our u value, we know that our u value needs to be sine x because the derivative of sine x is cosine x. Since we need our u to be sine x, we'll change our cosine squared value to its equivalent, which is 1 minus sine squared x, and multiply to distribute our sine values. This will leave us with the integral of sine squared x minus sine to the fourth power x times cosine x dx evaluated from 0 to pi halves. We'll go ahead and use u substitution with our u as sine x and our du as cosine x dx, and change our bounds from terms of x to terms of u. This leaves us with the integral of u squared minus u to the fourth power du, evaluated from 0 to 1. We'll finish solving this integral by integrating as we usually would and plugging in our bounds starting from top to bottom. So we'll be left with u cubed over 3 minus u to the fifth over 5. And we'll plug in 1 as our u value first and then our 0, and this will leave us with 2/15 as our final answer.